So height can be broken down into any number if you're precise enough, if you have like a very nice ruler. So here I would use either line graph or histogram. So once again here, this is time. For time, you almost always use line graph. It's important. And here you have number of students in a grade. I would use a bar graph here. I mean, technically, I guess you could use a circle graph, but I would use a bar graph. That's, yeah, makes more sense. All right, reading graphs. What did it tell us? Distributions. The distribution of a statistical data set is a listing or function showing all the possible values or intervals of the data and how often they occur. When a distribution of canonical data is organized, you see the number or percentage of individuals in each group. Types of distribution. In a normal distribution, about 68% of values are one standard deviation away from the mean. About 95% of its values lie within 2 standard deviations, and about 99.7% are within 3 standard deviations. This is just something that you have to memorize. Not something you have to know too much. What you do need to know is the mean. You need to know what mean means, and if you don't know, mean means average. So it's like the middle point is the average. In a skewed distribution, data points cluster more toward one side of the scale than the other, creating a curve that is not symmetrical. So here's an example of something that's symmetrical. You have a low curve and then a high, 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 and then the middle is the highest point, and then back to down is symmetrical. And here you have something that's not symmetrical, and it's skewed either to the right or left. In this case, this is called left skewed, where you have the really big point here. And it's called right skewed, where you have the little really big point early on, and then it goes down like that. Just this is more like memorization. You don't have to understand too much of this. A bimodal distribution is a continuous probability distribution with two different modes. These appear as distinct peaks. So this just means that you have two maximums or two highest points. That's called a bimodal. It's just, once again, you just have to be able to classify it. You don't have to do too much math explaining how or why these things happen. This is a grade 11 college course, so you don't really have to know, like I said, too much of the math involved when it comes to those distributions. All right, populations and samples. Population refers to all the individuals or items in a group being studied. This is actually important, this slide. Collecting data about every individual in a population is called the census. You need to know these three things. It is very difficult to obtain information from an entire population. This is very important, kind of like one of those test questions. You need to know this. A sample is a group of individuals or items that are representative of the population from which they are taken. So what does that mean? So let's say the Canadian population is, let's say, 40 million. We're just going to round to an even number. We're not going to, when we do a survey, we're not going to ask every single person that's 40, out of the 40 million to take that survey. That's impossible. It's going to take forever. We don't have the time, resources, money, manpower to do that. So what you do is you take a sample size. A sample size is a smaller amount of people that's representative of the 40 million. So you would have some categories of 40 million. Let's find out how many percentage are, like, let's say, based on, like, ethnicity or gender or like age or whatever. There's certain groups, and you would find, like, let's say maybe 1,000 or 10,000 people that are representative of the whole Canadian population. Let's say there's 40% females and like 60% males. Let's just give an example of the population in Canada. And in your 10,000, you should also have like 40% and 60%, or let's say 1,000, whatever. Let's say there's like age groups. Let's say like there's like 10% are under 18 of the Canadian population, and then like from 18 to, let's say 30, is like another like 20%, and from 30 to 40 is like 30%. Whatever the age groups are, you would then make your sample size reflect that. So you would have that many 18-year-olds or like 30-year-olds or 50-year-olds or 70-year-olds. So you would get a sample that's representative of the whole population. So you don't have to then take a survey of the whole 40 million. You can just use this 10,000 or 1,000 people to take the survey. If the sample does not reflect the population, it is considered to be biased. That's important. So if you don't do what I just did, which is try to get a sample that's representative, then it's called a biased sample. That word biased. There are many different ways to choose a sample. All right, population equals entire group. Sample is part of the group. You ask. Sampling techniques, simple random sample. Each member of the population has an equal chance of being selected. So you probably have, let's say, all 40 million people, names and a hat, let's say, or a randomizer, computer randomizer, and you just hit that randomize button, and every single person had a chance to get called. And whoever gets called, you do that like 1,000 times or 10,000 times, and then boom, simple random. Everyone had an equal, chance of doing it. Stratified random sample. The population is separated into subgroups, gender, age, etc., and the sample selected correspond to a number in each group. So this is what I was explaining, how you kind of, group the people into certain things like gender, age, and I don't know what else, but yeah. All right, other sampling techniques. Voluntary sample. The sample contains these members of the population who have chosen volunteer to participate in the sample. So you can always, have a survey, be like, hey, who wants to volunteer to, be part of my survey? And then whoever, comes, those are obviously a volunteer sample. Cluster sample. The population is divided into groups that are similar in nature, and a certain number of groups are selected. Every member of the group is part of the sample. So that's called a cluster sample. Convenience sample. The sample contains those members of the population that can have data collected from them with relatively ease. Systematic sample. Every nth member of the population is selected. What does that mean? That means like if you had the 40 million, each person was assigned, let's say, a number. Person number 1, person number 2, whatever. And let's say every 1,000th person or every 10,000th person is going to be selected. So that's systematic. You just randomly pick the same number of person. So like first person gets chosen, and then the 10,000th person gets chosen, and the 20,000th person gets chosen, 30,000, whatever, depending on whatever the nth number is. Judgment sample. The person doing the sampling chooses the sample based on his or her knowledge of the population. All right, we got leading and loaded questions. Need to avoid these. So when you create your own survey, you need to not have these. What are leading and loaded questions? A leading question is a question that prompts or encourages the answer wanted. Do you have any problems with your teacher? That's an example. So that's a leading question. A loaded question is a question that contains implicit assumptions. Are you still using drugs? So, like the way you ask these questions, the way you word these questions, it kind of affects the response from the person that you're asking, right? Like, by now you should be able to present data using a circle graph, bar graph, histogram, and line graph, and describe how to create a questionnaire. So, like for the loaded question, I would say instead of get rid of the still, you could say, "Are you using drugs?" I think that's easier. Or do you have any problems with teacher? Maybe is your teacher? I don't know. Actually, that's a good question. How would you change that to make it more less leading? Think, is your teacher problematic? I think maybe, yeah. I think that seems a little bit more neutral. Instead of do you have, like, you get the you out of there. And just feel like, is your teacher problematic? Like, don't have like, like you, or are you still using like the still part? All right, now what? All right, what should we work on? Today's content. You need to do 2.1, collecting data. 2.2, storing and organizing and analyzing data. And then statistics to make decisions. The following activities are due at 11:59 p.m. tonight. You have your mini tests. The summative test is due, apologies, this is wrong, is due tomorrow. It is not due today, so I should get rid of that. That's due tomorrow. So these aren't always 100% accurate. This part, like my announcements, are what's more accurate, because we kind of reuse the slides. So the dates might be off. Anyways, due tomorrow. Once again, this may not be exactly accurate. That's it. What you need to do now is go here. Well, this is not the website. Your thing is here. Contents. Unit 2. Lesson 1. Lesson 1, collecting data. Go through this. 2.2. This one, and 2.3. This one. I believe that is. Yeah, that's what you need to do. Oh, sorry. Actually, I made a mistake. So this is actually tomorrow's work. Today, you're just supposed to be reviewing. Apologies for that. Today, you're supposed to be reviewing for your test that's due tomorrow and completing quiz 4. Tomorrow, you will be doing 2.1, 2.2, 2.3. So we went a little bit ahead, so that's fine. Because when it comes to quadratics, we're gonna kind of get back in. I already checked it. Because this is a bit easier. Quadratics, we need a little bit more time, so I'm spending a little bit more time on the quadratic section. So yeah, that's it. That's it for today. You just have to review. Make sure you're submitting the work, and make sure you're doing quiz 4. That's all you really need to do today, and study. If you want to go ahead, you can obviously do chapter 2. So July 1st, 1 quiz today, and tomorrow is the assignment. So at this point, since you have some extra time, it's for questions. So any questions that you may have now? No, Ashok, you're okay. All right. Anyone else? If not, we can leave a little bit early today. So it's up to you guys. Like just 10 minutes. No questions at all. Okay. Wow, that's the first. I usually get a lot of questions when it comes to submitting stuff. Sure.